Okay, hello everyone and welcome to S-Cuprec Academy. It's a success-based academy which is aimed at assisting students both online and on-site with quality education. So for this lesson, we are going to begin with the number system. The course we are going to be covering here is ordinary level mathematics, and we are going to cover the whole syllabus as far as the GCE Cameroon is concerned. So I warn you that if you haven't subscribed yet, please kindly click the subscription button in our channel so that whenever we upload a new video, you will be alerted. Because this is topic 1, as we are beginning with it, the other topics will be coming up. Okay? So in today's lesson, we are going to begin with the number system. And for real, we are going to be GCE based. So the very first concept we are going to look at under the number system is the various types of numbers. We are going to look at the various types of numbers. So the very first one I want to begin with is the set of natural numbers. The set of natural numbers here is the symbol. And these are simply a set of counting numbers excluding 0. All numbers you can imagine, positive whole numbers excluding 0. So generally, if we are talking about the set of natural numbers, then we are talking about the set beginning from 1, 2, 3, right up to a certain positive infinity. So natural numbers are simply what? All positive whole numbers, okay? Excluding 0. 2. Whole numbers. Whole numbers, you will denote it by W. Okay? Whole numbers now is the same. They are the same as natural numbers, but now the only additional thing is that it includes 0. So if we are talking about the set of whole numbers, W, then we are talking about the set beginning from 0. 1, 2, 3, 1, 2. So what do you notice? You notice that all the elements that are found in the set of natural numbers are found in the set of whole numbers. Also, very good. So the third, we're going to look at the integers. Integers. We're going to represent it by this symbol. Now, what do we need to know about integers? They are simply what? They include positive whole numbers, 0, and negative whole numbers. Okay? So, what do we mean? If we're talking about the set Z, that means it begins from a certain negative infinity. Let's just start from negative 3. Assuming there may be some numbers, there were some numbers before negative 3, negative numbers this way. Okay? So from negative 3, we can go to negative 2, negative 1. After negative 1, we go to 0. We go to now to the positive part. 1, 2, 3, and so on, right up to positive infinity. So what do we say about integers? It includes positive whole numbers, negative whole numbers, and the number 0. So what do you notice? You notice that what? All the elements that are found in the set of natural numbers are found here. All the numbers that are found in the set of whole numbers are found here. Okay? Very good. Now, NB. You have to note that negative 3 on 5 is not an element of Z. Because elements of Z, we're talking about whole numbers only. Either negative whole numbers, positive whole numbers, and including 0 as well. Very good. So the fourth type of number we're going to look at is a rational number. Rational. Now let's denote it by cure. Rational numbers are simply numbers which are written in the form A on B, where A and B are the elements of Z. That means A and B could be any integer, -3, 1, 4, and so on. But you have to know that word. B should not be equal to 0. Because if B becomes 0, it becomes undefined. So any number of the form A on B, decimal, is said to be a rational number. Okay? Very good. So irrational number. Irrational. Let's denote it by cure prime. Now, these are numbers that cannot be expressed as repeating decimals. For example, we could talk of numbers involving root signs. For example, root 7. We could talk of constants like pi, and so on. So those are examples of irrational numbers. Very good. 6. Now, what all of us know from class 6 primary school, we have another set of numbers called the even numbers. Now, the even numbers are simply those numbers that, when divided by 2, leaves no remainder. And generally, we just say that even numbers always start from, we're talking about a set, it always begins from 2. You begin to add 2 consecutively, okay? So we have 2 plus 2, we have 4, plus 2, we have 6, plus 2, we have 8, and so on, right up to a certain positive infinity. Okay? So that's the set of even numbers. Any number that when you divide by 2, it leaves no remainder. For example, 100 divided by 2 is 50. So this means that 100 is an even number because it leaves no remainder. But if we take something like 3 is not an element of an even number. No, it is not. Why? Because 3 divided by 2 is what? 1.5. And it is not, you see that it is already decimal, that means there's a remainder. So you have to be careful. So permit me to write this way. Oh, let's proceed, okay? So now the next type of number is odd numbers. Odd. Odd numbers now in this case are numbers that when you divide that number by 2, is going to leave a remainder, or it's going to give you a decimal if you punch in your calculator. For example, odd numbers begin from 1. Okay? 1. You begin from 1 and you begin to add 2 consecutively to it. 1 plus 2 is 3. Plus 2 again we have 5. And so on right to positive infinity. Okay? So take note of that. The next series of numbers is what we call the prime series. This is where a lot of students always face difficulty understanding. But now I'm here to make things easy for you. What is a prime number? A prime number is simply that number that can divide only 1 and itself, with the exception of 1. That means that 1 is not a prime number. You begin checking prime numbers beginning from 2. So, if we have to talk about a set of prime numbers, let's play the game. A prime number must be able to divide only 1 and itself. Beginning from 2, 1 is an exception. So, 2, is 2 a prime number? Is 2 a prime number? Yes, because 2 can divide only 1 and itself without a remainder taken. You go to the next number, 3. 3 is a prime number because it can divide only 1 and itself. If you divide it with any other number apart from 1 and itself, it gives you a remainder. For example, 3 divided by 2, we see it is a decimal. So, the next number is 4. You see that 4 can divide 1 and itself, true. But now, 4 divided by 2 is 2, no remainder. So you see that what? 4 is not a prime number because it can divide another number without a remainder apart from 1 and itself. So 4, this makes 4 not to be a prime number. So let's go to 5. 5 is not a prime number. 5 can divide only 1 and itself. And due to that fact, it makes 5 a prime number. 6. 6 is not a prime number because 6 can divide 1 and itself. Very good. But now you can also divide 3. You can also divide 2 without a remainder. 6 divided by 3 is 2. Now so 6 divided by 2 is 3. So you see, it fails. Now so you go to 7. 7 is a prime number because it can divide only 1 and itself without a remainder. And so on. Okay? You can continue testing. And so on. Now the next series of numbers is what we call the square numbers. Okay? The square numbers. Square numbers are numbers that are obtained when you multiply an integer by itself. For example, if I take any integer 1, 1 times 1 is 1. So this means that 1 is a square number. A square number is that answer obtained when one integer is multiplied by itself. We go to 2. 2 times 2, multiply 2 by itself. Answer is 4. So 4 is a square number. 9. Same thing. 3 times 3, 9. So 9 is a square number. So that's how we get square numbers, okay? Cube numbers. Now a cube number comes about when you take a square number and multiply by, let's say that number was A. You take the square number of that value and you multiply by itself. Or in simple terms, a cube number comes about when you take an integer and multiply by itself 3 times. For example, if you take 2 times 2 times 2, what do you see? You see that 8 becomes a cube number. If you take 3 times 3 times 3, that's 27. You see that 27 also becomes a cube number. Okay, before we take a few examples, we are done with cube numbers. Now I want us to look at the set of real numbers. That is the set of real numbers denoted by this symbol R. Now this guy is called the Oga Pata Pata, the overall. This guy is a constituent of all of these guys. All of these different types of numbers we have seen are found under the set of real numbers. Okay? So this guy consists of all of these other types of numbers. That means all of these types of numbers are subsets of this guy. Take note. It is a set of all numbers that exist, including all the different types of numbers we have seen already. So that's it. And that's all about number system, part A. So it is necessary we are going to look at some exercises for better understanding to see how the GC always set questions, okay? And this is very necessary, so let's pay attention. So, in these exercises, we're actually going to be answering true or false, okay? So let's follow through. So the very first exercise is -7 an element of the set of integers? True or false? It is true. Why? Because we know that integers consist of negative whole numbers, positive whole numbers, and the number 0. Not so? Very good. So this is true. 2 is -3 on 2, an element of the set of integers. I know most of you will be confused. You will say that, okay, since it is negative number, it is a set of integers. No. Or you'll be thinking that, no, since it belongs to what? Any number of the form A on B, where B is different from 0, is said to belong to the set of rational numbers. So don't be confused. This is not an integer. So the answer here is simply false. Okay? Very good. Number 3. Is 4 on 2 an element of the set of natural numbers? Most of you will still be confused at this point. You will say that no, 4 on 2 is from the set of rational numbers. No. You have to realize that 4 on 2 is the same as what? 2. 4 on 2 is the same as 2. So the question is indirectly asking you, is 2 an element of the set of natural numbers? Which is simply true, right? Very good. So you see that the answer here is true. Most of you will have taken false because of the form A on B. Always try to simplify to the fullest first before you conclude. 4. Is the set of natural numbers a subset of the set of integers? What does this mean? They're asking you if all the elements found here are found in this set. True. All of these elements are found here. If you look at the previous page, the first page that we covered, you will see. So this is typically true also. Very good. Now, second to the last question. Is this a subset of Z and as well a subset of R? You have to say that this is typically true. Because if this is a subset of this, if this is already true, you have to test for this guy. You start asking yourself, are all of these 2 guys found in this other guy? That's the meaning of this statement. You see that all of these 2 guys are found here. So this makes this statement to be what? True. Because this is the Oga Pata Pata. You understand? Very good. Now, the last exercise per se is going to be something structural. You can be asked to list prime numbers. You can be asked to list prime numbers. Let's say less than 6 and, less than 15, for example, and greater than 6. What does this mean? This means that the prime numbers should be less than what? Should be less than 15. meaning you should not go above 15. You should also be what? Greater than 6. That means you should not go below 6. You should start above 6. That means you begin maybe from 7. Okay? So you want to answer this question. What are we going to have? We begin from something greater than 6. That's the next number to 6 is what? 7 also. So we begin from 7. Is 7 a prime number? Yes. Because it can divide only 1 and itself without a remainder. We go to 8. Is 8 a prime number? No. Due to the fact that 8 can divide other numbers apart from 1 and itself without a remainder, like 2, 4, it makes it not to be a prime number. We go to 9. 9 is not a prime number because due to the fact that it can divide 3. 10 is not a prime number due to the fact that it can divide 5. For something to be a prime number, it must be able to divide only 1 and itself without the remainder. Okay, we go to 11. Correct. 11 is a prime number because it can divide only 1 and itself. Any other number you bring in, there will be a remainder. Or when you punch your calculator, you're going to something like a decimal. 12 is not a prime number because it can divide 4, it can divide 3, it can divide 6, and so on. 13, correct. 13 is a prime number because it can divide only 1 and itself. 14, no. 14 can divide 7, so it is no more a prime number. There is no need for you testing 15 because they said it should be less than 15. So you end at this point. And that is the big tick. And there are other ways in which you can set questions. They are going to ask you, from the options below, which of the following is a prime number? And they give 14, 3, 10, and 9. Which of them is a prime number? You have to choose. The only prime number among these options is what? 3. And that's the correct answer. Which of the following among the options is a cube number? Which of the following among the options is a square number? It's an odd number, it's an even number, and so on. So that is it. And I'm so happy that we have come to the end of this part 1 of the lesson. And please, if you haven't subscribed, make sure you click on the subscription button so that whenever we upload a new video, automatically you'll be alerted. Remember, this is a whole course that we have promised to take you all through till the end, as far as the GCSE levels are concerned. Thank you so much.